Hello everyone, welcome to the course on Pushover Analysis using SAP 2000. And in this lecture, we'll see the benefits of Pushover Analysis. So why we are using Pushover Analysis? What is the requirement? Why we are saying that using nonlinear analysis, using nonlinear static Pushover Analysis is better than linear static analysis. Okay, so in this, we will see that. So first of all, when we talk about Pushover Analysis, it mainly identifies weak zones. In case of linear static analysis, we do not get these kind of identifications like where the weak zones are. Yes, we have a basic idea, but we do not understand what kind of deformation will take place, what kind of behavior will be there at the weak zones. So it detects weak members, plastic hinge locations, and potential failure mechanisms. Second is performance-based assessment. As I said in previous courses also, the previous lectures also, that performance-based analysis we are doing it and performance-based design is incorporated using pushover analysis. We see different performance levels, that what kind of performance the building is giving. So it evaluates structural performance levels, immediate occupancy, life safety, and collapse prevention under increasing seismic demand. Third thing is it is very simple and efficient in comparison to non-linear time history analysis. Pushover analysis simple and efficient, easier and faster than non-linear time history analysis while still capturing inelastic behavior. Usually, the simple and efficient, faster ways do not capture the inelastic behavior, but pushover analysis does. Second, one more thing, it provides capacity curve. What capacity curve is, we discussed earlier also. So it shows overall strength and deformation capacity of the structure. Pushover analysis also checks code compliance. It is useful for performance evaluation as per FEMA, ATC 40, IS 1893, and other guidelines. The next and very important point, it helps in retrofitting decisions. Basically, when we talk about pushover analysis, I still remember that when I was studying it for the first time, I was very astonished to know that in case of pushover analysis, we can analyze the already designed buildings. Like, for example, a building, say this is a building and this is already designed, it is in work, okay, in service it is, but it has been from a long time, and we still want to say that whether it is able to withstand any earthquake or not, what kind of seismic activity it can withstand. So we can see and check and analyze it using pushover analysis, and then we can find the weak points in the building, and then we can retrofit it to make it better, to make it less vulnerable. And this is how push analysis works. And it is a very good point that it identifies where strengthening or modification is needed, and it helps in retrofitting decisions. One more important point, it visualizes progressive failure. When we'll be doing it in software, I will show you that how we can see the progressive failures using push or analysis. It demonstrates how failure propagates through the structure as loads increase. We'll see that later. Next, supports equivalent linearization. Okay. It enables simplified estimation of performance point using methods like ATC 40 and FEMA 440. I will show that in SAP later. But actually, what happens that usually these things are complex. So, and these things are not linear also, as I'm talking about non-linear analysis. But using equivalent linearization, very famous for FEMA 440, Federal Emergency Management Agency, and ATC, Applied Technology Council. They provide equivalent linearization curves, which shows performance point where seismic demand and capacity meets. We'll discuss it later. You don't need to worry. We'll discuss it very clearly. So it supports that kind of feature, which we do not get in static methods, linear methods. Next, it is very useful for irregular structures. When we talk about linear methods, we do not account for the irregularity. But in case of pushover analysis, we can see that. So it captures non-linear behavior in vertically irregular buildings or soft story buildings. Basically, what soft story is a kind of stiffness irregularity when the floor above and a floor below it is compared. So the floor below has less stiffness than the story above or the floor above. It is said to be a soft story or stiffness irregularity. The last but not the least, it is cost effective. It reduces the need for expensive and complex time history analysis during initial assessment. So we can minimize the cost also and get a very proper prediction, proper demonstration, proper progress in the field of structural analysis, in the field of seismic analysis. So this is why we are going towards pushover analysis, and this is why it is very important to read it to understand it. So that's all for this lecture. Thank you so much. We'll see more interesting things later in the other lectures. Thank you.